I need to learn to read my attendance better. It's the person above you. Ben, you got it? Are you ready for weirder but cooler? Here we go. I've already told you that there's no way to measure time accurately. There's no way to prove that my time is correct compared to your time. Savannah, if you are moving, you are experiencing time differently from me. We finished off last day looking at traveling 1,000 years into the future. This would be doable because how old are all of you? You're 16 or 17. If you go 44.7 plus 16 or 17, you would arrive back here. You would be about 60 years old, but you would arrive in the year 3018. Now, it's a little more difficult than I've let on because the Earth is not at rest in the universe. The Earth is orbiting around the sun and the solar system is moving through the Milky Way. So if you actually did do this, you would have to calculate where in the Milky Way the Earth will be 1,000 years from now. Newsflash, not where it is right now. And so you'd have to take that into account. But otherwise, sure. Oh, and if you had invented some kind of freezing technology or cryosleep technology so that you didn't age 44.7 years, so that you were able to kind of freeze yourself and sleep and wake up still being at age 16, that might happen in the future. Who knows? But I promised you weirder. Here it is. I like example 5. I like example 5. I like example 5. Example 5 is a nice question. Proxima Centauri is the closest star to the Earth. It is. It's 4.24 light years away. What's a light year? A light year is a measure of distance. It's how far light would travel in 1 year. It's big. The sun is about 10 light minutes from us, and the sun is a fair distance away. So Proxima Centauri is 4.2 light years away. Suppose we build a spaceship that can travel at 80% of the speed of light. How long will it take the spaceship to get there as measured by the stationary observers on the Earth? So are the people on the Earth moving? So we don't need to go all relativistic. We don't need to use the T and T0 equation. We still are going to say T equals question mark. We are still going to say for this whole unit, A is 0. What's D? D that we want to travel is 4.24, and my abbreviation for light years is L period Y period. And I always make my lowercase l, Adam, as a cursive, because if I make my lowercase l like that, what number does that also look like? So it's just a habit. I've mentioned this to the kids at the beginning of the year. I'll always make my lowercase l as a handwritten cursive L. What's the speed? 80% of the speed of light. How do we write that? We don't write that as 0.8. Of the speed of light, we write it as 0.8. C, don't forget that. Of the speed of light. Otherwise, that's a nonsense number. Otherwise, you'd be saying it was going 0.8 meters per second or something silly, which is crazy slow. Don't forget the of the speed of light. Now, are we moving? Is the Earth moving really, really fast according to this part of the question? Yes or no? It's meant to be really obvious. Riley? No. So we're not going to use our relativistic. We're going to use good old D equals VT. I'll change colors so it stands out a bit. We're going to use good old D equals VT. Riley, how would I get the T by itself? How will I move the V over? What's the V doing to the T? Adding, subtracting, multiplying, or dividing? So I'll move it over by. So you're telling me in this equation, T equals D over V. Again, let me emphasize this is for the Earth, so I don't need to go all relativistic. What's the distance? 4.24 light years. What's the speed? 0.8 C. Look up for 1 second. Look up for 1 second, everybody. What does the letter C stand for? The speed of? What does this L stand for? The speed of? So I can say these kind of cancel. They're not the same letter, but light is going to cancel out of this equation, Sam. Trust me. You want to know how long it's going to take? It's going to take 4.24 divided by 0.8, which is what? Exactly? 5 point even? And that's in years, so now I'll bring my A for annual. Okay? So as far as we're concerned, it's going to take, let's pretend you're all the astronauts. As far as we're concerned, to travel 4.24 light years to the star, it's going to take you 5.3 years. So let's suppose it takes you 5.3 years. You stay there for a year. How many years is that? 6.3. And then you come back. So add another 5.3. We're going to expect to see you 11.6 years from now, roughly 12 years from now. So 2018, we expect to see you all in 2030. You okay with that? On the spaceship, how long do you feel that it's taking? Are you moving really fast on the spaceship? You're going to be affected by relativity. What time is this question asking us to find? What time is this question asking us to find? T0. What was the time back on the Earth? 5.3. See what? That's why I had to do that first. How fast are you all traveling? 0.8 what, Antonio? 0.8 what, Antonio? Don't forget the C. So now relativity is going to kick in. Look at your relativity equation. Get the T0 by itself. What's my equation going to be? T0 equals. How would I get the T0 by itself? Courtney, you're looking at the relativity, the T equation, yes? What's that square root doing to the T0? Adding, subtracting, multiplying, or dividing? So how do I move it over? So you're telling me it's going to be T times the square root of 1 minus V over C all squared? So 5.3 years back on the Earth, square root of 1 minus 0.8 C over C all squared. Do you see? Do you see? Do you see? What do you see? The C's cancel, yes? How many years on your watches will you think the trip takes? Let's see. 1 minus 0.8 squared. Square root of that times 5.3. 3.18? 3.2, 3.18? I'll go the 3 sig figs. Oh, good. I type what's inside the square root first, so I went 1 minus 0.8 squared, and I hit equals. Do that. Yes? And then that's inside the square root, so I went square root answer button. Got that? And then it's times 5.3, so 5.3 times answer button, or answer button times 5.3, and I got 3.18. Yeah? How far away from us is Proxima Centauri? How many light years? What did the question say? So let me ask you again. How far away is Proxima Centauri? No. Yes? No. How far away do you all measure it in your spaceship? Well, for you, distance equals speed times time. How fast are you traveling? How fast are you traveling? It's not 0.8. What? Stop forgetting the C. I got to be grumpy, okay? You're traveling at 0.8 of the speed of light. How long are you traveling for according to your watches on the spaceship? So How far do you measure the trip to be? From the Earth, we measure it to be 4.24 light years, but when you actually go there, if you were rolling out an imaginary galactic tape measure behind you and measuring the distance, what will you measure it to be? Oh, by the way, look up for 1 second. It's 3.18 years. Look up, look up, look up, look up, look up. Everyone look up. Can you see we're going to get an answer in light years? Ah, that's why I barked at you about the C. So if I ignore the C, but I know this is going to give me an answer in light years, I'm going to go 8 times 3.18. Sorry, 0.8 times 3.18. Better type that in properly. I get 2.54. Light years. So here's what that means, Evan. Not only is it impossible to say time accurately between moving objects, you can't measure any distances accurately in space either. You'll get a completely different answer if you're moving versus if you're at rest. There is no way to say how far apart stars are, or how far apart galaxies are, or how far apart planets are. It depends if you're moving or not. You'll get a different answer if you're moving. Come on, that's a little creepily weird too. There's no such thing as distances if you're moving at relativistic speeds. You can't tell me that your answer is right. You astronauts would measure the distance to be 2.54 light years, even though we measured the distance to be 4.24 light years. How much time elapses if you're traveling at the speed of light? Let's suppose we build a magic spaceship and it's going at the speed of light. So we would like to find time on board the spaceship. Okay? Let's just put time back on Earth. Let's just call it T. I'll come up with a number in a second, but for now, I'm going to say time back on Earth, T equals T. What's our speed if we're traveling at the speed of light? 1c, and I'm just going to write c because there is an invisible 1 in front of it automatically. Is there not? Yes? We'd like to find t0. Courtney, how would I get the t0 by itself in our time dilation equation? What will I do with that square root? So you're telling me that the time on board the spaceship is going to be t square root of 1 minus c over c all squared. Yes? Wait a minute. What is c divided by c? What's 5 divided by 5? What's 8 divided by 8? What's c divided by c? So really, this leaves a 1 behind. We're going to do this in our heads. What's 1 squared? What's 1 take away 1? What's the square root of 0? 0. What's 0 times t? What's 0 times anything? What does that mean? If you're traveling at the speed of light, you don't experience time. So, even though from our stationary reference frame on the Earth, we like to say when we look out at night at the stars that it took the light from the stars thousands of years to reach us, or hundreds of thousands of years to reach us, or millions of years to reach us. As far as the star's light is concerned, as far as the photons are concerned, the trip was instant. As far as the beam of light is concerned, it left the star, it arrived at the Earth at the same time. As far as we're concerned, we think it took it millions of years to reach us, but the light didn't experience time at all. I've just turned on my phone flash. photons are leaving my phone. Particles of light are leaving my phone. Those photons don't experience time. Even though I just turned my phone on, as far as the photons are concerned, because they don't experience time, those photons saw the Big Bang and saw the end of the universe. In fact, they're seeing both right now at the same time because they don't experience time. Light is special. Photons don't experience time. Objects moving at the speed of light don't experience time. A spaceship traveling at 2.85 times 10 to the 8th meters per second leaves the Earth and returns to the Earth 100 years later. How much time has passed for those living on the spaceship? Okay. What's this question asking me to find? Time. Which one? So I guess T is 100. What's V? Don't overcomplicate this. What is V? Read it to me. 2.85 times 10 to the 8th meters per second. This time they didn't give it to me as a percentage of the speed of light. So this time I'm not going to tack on a C because it doesn't have that phrase of the speed of light. So V is going to be 2.85 times 10 to the 8th meters per second. And unfortunately what that means now is do you see is not going to work. So I'm going to have to include C. What's C? It's on your green sheet. 3 times 10 to the 8th. So every once in a while, instead of giving you the speed, it's on the relativity section, Antonio, right? On the back page. All the relativity stuff is on the back page. See it there? Do you see? Yeah. Every once in a while, Logan, instead of giving you the speed of the spaceship as a percentage of the speed of light, I'll give it to you in meters per second. Okay. Courtney, what are we trying to find? How would I get the T0 by itself? Okay. So T0 is going to be... Do you think we can maybe try plugging the numbers in without writing out the formula first? Let's try it. So 100, great big square root, 1 takeaway, and this time I'm going to have 2.85 times 10 to the 8th. That's where the V is. There's not a C tacked on, so I can't say, do you see? So it's actually going to have to be over 3 times 10 to the 8th. All squared. Kelsey just figured out some questions on the homework. I saw your eyes light up. Oh! Okay, how am I going to type this? I'm going to encourage all of you to get your calculator out and follow along with me. Now what I would do is I would type this little mini fraction first. I'm going to go 2.85, scientific notation button. Remember where that is? 8 divided by 3, scientific notation button, 8. And you should get 0.95. If you didn't, you've forgotten how to do scientific notation, and I'll help you with that later in class. So if you didn't, just clear your calculator and type 0.95. What's this fraction inside of? What's right outside the brackets? So squared equals. Now what? 1 minus that equals. Now what? What? You missed something. Yes. Square root button equals. Now what, Riley? Times by 100. 31.2 years on the spaceship. So as far as I'm concerned now, Ben, it's fair game for me to give you the speed as a percentage of the speed of light or in meters per second. Meters per second is a bit more of a pain, more typing. Yeah. I'll come look at it later. Oh, you figured it out? Okay. I like example 8, I like example 8, I like example 8. Example 8 is a nice question. What's example 8 asking me to find? Ooh, what is example 8 asking me to find? So which variable is the how fast in our time dilation equation? V. Okay. V equals question mark? Did I give you the V equals equation? Because some years I have and some years we've derived it. The derivation is a pain. And if you're bored sometime, believe it or not, you could handle it. I would start out with the T equals T0 and I would get the V by itself. And it's kind of cool. But let's just list our data. That 20, is that 20 T0 or T? How do you know? And I went to the other one on the spaceship. Yeah, T0 is 10. So T0 is 10. T is 20. In other words, what I'm really asking here, Sam, is how fast would you want to travel? Would you need to travel if you wanted time to go half as fast for you as back home? If you wanted a nice 2-to-1 ratio. Okay. Adam, can you read to me the V equals equation? Because I've forgotten it, and I really have. On your, sorry? The one with T's in it. There's also one with M's in it, and there's probably one with L's in it. And we're going to look at what happens to mass and length next class. But for now, the one with the T's in it. Yep. C, speed of light, times the square root of
1 minus T0 squared over T squared.
And I can either write it like that, or I can put the squared on each one, right? You'll notice all three of the V equations look kind of similar, but a little different tweaks. Is that the correct one? Is that right? Okay. Don't put in the C just yet. Instead, I'm going to go like this. V equals, I'm going to leave the C as a C. Square root of 1 minus 10 over 20 squared. How will I type this in? I'll probably do that little tiny bracket first. Now, 10 over 20, I know that's 0.5, but if it was numbers that were more complicated and you didn't know how to do them in your head, I would go, okay, 10 divided by 20 equals, then what would I hit? Then what would I do? Not yet. I've just done the bracket. What's outside the bracket? Squared equals, then not minus 1, 1 minus that. I have to go in the correct order, yes? 1 minus that thing equals, then what? What's next? Square root. And I get this, 0.866 C. I left the C in front, but instead of putting the C in front, we're used to having the variable afterwards, yes? Hey, what percent of the speed of light is that? Can you be more fussy? 86 point what? 86.6% of the speed of light. Okay? So, V equals 86.6% of C. What if they wanted that in meters per second? This question didn't say. On the test, I would tell you whether I wanted the answer as a percentage of the speed of light, 0.866 C, 86.6% of the speed of light, or in meters per second. How would I convert that to meters per second? Good stretch, Evan? Good. Evan, my friend, can you read me this out loud, please?
86.6% of C.
Okay. Do you all know what the word sum means in math? If I say two numbers have a sum of 10, what mathematical operation does sum, S-U-M, mean? Add. Do you all know what the word product means? What mathematical operation is that? Multiply. Do you know what the word of almost always means? It means times. The only time it doesn't mean times is if it's 3 to the power of 7, because the word of appears there, then it's an exponent, which is a bit different. But do you know how I'm going to convert this to meters per second? Do you know what of means? How big is C? And I have to change this to a oh, you know what? Actually, rather than change this to a decimal, I'll walk back to here, and I'll actually go 0.866 times 3 times 10 to the 8th. That'll be the answer in meters per second. And I'll get 2.598. That's a good place to round off, I think, yes? Times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Meters per second. Okay. So as far as I'm concerned, Ben, I can ask you to find the speed now, but I have to tell you how time passed in both locations. Oh, and I can ask you to find the speed in meters per second or as a percentage. As far as I'm concerned, I can give you the speed in meters per second or as a percentage. I can ask you to travel to planets and compare the traveling distance versus, in light years, the distance that we measured from the Earth. So what's your homework? I already assigned skip 4, 1, 2, 3, 4, 6, 7, sorry, 1, 2, 3, 6, 7, 8, 10. 11 is good. I'll skip 12. 13 is good. 14, 15. 16, 17. 18 is good. Oh, I've got to do number 19. 20, 21. Here is your answers, and I'm going to print up a handwritten answer key because sometimes you're just wondering, how the heck do I type this into my what goes where calculator equation? So I'll print up a handwritten showing all my steps answer key, and I'll also put a handwritten answer key on pitmath.com. Oh, and next class, it gets weirder, but cooler, but weirder.